Welcome you all. In this session, we are going to discuss the bus impedance matrix by building algorithm. Outcome: after successful completion of this session, the student would able to form the bus impedance matrix by building algorithm. Bus impedance matrix building algorithm. So, in the previous session, we discussed about the impedance matrix by Thevenin's equivalent circuit. So, the reduction of network to find the value of Thevenin's impedance is difficult for complex network with more number of branches. The Thevenin's impedance can be obtained from Z-bus matrix. So the Z-bus matrix can be obtained by taking the inverse of Y-bus matrix, but normally it is obtained by using Z-bus building algorithm. So the step-by-step procedure to determine Z-bus matrix is explained in the following session, by using the building algorithm. So the bus impedance matrix of power network can be obtained by inverting the bus admittance matrix, which is easy to construct. However, when the order of matrix is larger, direct inversion requires more core storage and enormous computer time. Therefore, inversion of Y bus is prohibited for large size network. Bus impedance matrix can be constructed by adding the network elements one after another, one by one. Using impedance parameter, perform the equation in bus frame of reference can be written as E bus is equal to Z bus into I bus. In the expanded form of the above equation becomes E bus, it is a column matrix of the E1, E2 up to En, which is equal to Z bus, Z11, Z12, it goes on up to Z1n, and in diagonal it goes on up to Znn. So it's a square matrix. And the third one is the current matrix. That's again a column matrix of I1, I2 up to In. So we can, from this we can write EP is equal to ZP1 I1 plus ZP2 I2 plus it goes on up to ZPQ IQ plus up to ZPN IN. From the above, it can be noted that IQ is equal to 1 per unit, other bus current set to 0. EP is equal to ZPQ. Thus, ZPQ can be obtained by measuring EP when 1 per unit current is injected at bus Q and leaving other bus current as 0. In fact, P and Q can be varied from 1 to N. While making measurements, all the bus except one are open circuited. Hence, the bus impedance parameters are called open circuit impedance. The diagonal elements in Z bus is known as the driving point impedance, while the off diagonal elements are called the transfer impedance. For example, let us consider this problem. Consider a power system shown in figure. The values marked are per unit impedance. The per unit reactance of generator 1 and 2 are 0.15 and 0.075 respectively. Compute the bus impedance matrix of generator transmission network. So here the system is given. So here you can see in this power system, given system, you have three buses: bus 1, bus 2, and bus 3. You have three bus 1, bus 2, and bus 3. So the bus 1 is connected to the second bus and third bus, and the second bus is connected to the first and third, whereas the third bus is connected to 1 and 2. Again, the bus 1 is connected to generator 1 and 2 is also connected to the generator 2. The impedance value of the bus 1 to 2 is J0.1, and from 1 to 3 is J0.1, as well as from 2 to 3 is also J0.1, and the reactance of generator 1 is given that 0.15 per unit, and the generator 2 is given as xg2 is equal to J0.075. It is mentioned in the question itself. So the solution goes like this. The ground bus are numbered as 0. So here the ground bus, see, you can see the ground bus are numbered as 0 and taken as the reference bus. The per unit impedance diagram is given. So here the impedance diagram is plotted and the impedance value is represented along with it. When the elements 0 to 1, see, from 0 to 1 they have only j 0.15. From 0 to 2 you have two elements 0.15 as well as this one also. So that is what the z bus. Next, from 1 to 2 you have the next element. So on from each and every step, each reactance value is added to frame the z bus. So element 1 to 2 is added. So while adding 1 to 2, you'll be getting z bus is equal to 1 to 2. That is, you'll be getting this matrix. So z bus is equal to j times of 1. So each element is added for each step. So now from 1 to 3 you'll be getting a 3 by 3 matrix of z bus, and finally the element 2 through 3, it takes place in bus 2 to 3 with a j term of, it's a matrix of 4 by 4 matrix. Finally z bus is equal to, you got a 3 by 3 matrix. Thank you.